My name's Harriet. I hack your AI, so the bad guys can't. Welcome back to Harriet Hacks, not just for another week, but also for another year. We made it to 2025, everyone, and I hope everyone had a really joyful and relaxing holidays and New Year period, and that you're ready for some AI security in 2025, among other things, of course. Now, if you are new to this channel, my name is Harriet Farlow, aka Harriet Hacks, and I care about AI security. I worked at the intersection of data science and cybersecurity for about 10 years. My PhD is in adversarial machine learning. I now run an AI security company. It's all about applying cybersecurity methodologies and mindset to the field of AI. So if you haven't already, please do me a favor. It really helps if you could like this video, subscribe to the channel, and please comment below. Positive comments, ideally. Contribute to the conversation. Let me know your thoughts. Let me know your experiences in industry and in your own roles. I think it's really great, and I want to foster a community of AI security collaborators here. But with that, the thing I wanted to talk about today is, I know that in previous videos I've spoken through a piece of research that we recently did, which was basically trying to quantify AI risk, and involved going through lots of different incidents, AI safety, AI security, it's all obviously a bit of a blend, but going through all these incidents and trying to understand some patterns and ideally what we can do to prevent any AI incidents happening in the future. And one key theme that I noticed coming out of this analysis was actually the difference between AI security and machine learning security. So that's what I want to talk about today. I want to talk about the difference between AI security, ML security, whether there is a difference, what that even means, and that also touches on this other field called ML SecOps. So let's get into it. So something that I noticed as I was doing this analysis was that it really depended on the frame of reference as to what a specific attack looked like. And in my day-to-day dealings, working in AI security, I notice already that people have really different ideas of what AI security means. The most common interpretation of AI security that I hear is that I'm using AI to do security, so either offensive or defensive security and cybersecurity. Whereas what I mean is that I'm securing the AI systems themselves. Now, I noticed a sub-definitional or sort of thematic, paradigmatic issue as I was doing this research, and that was whether we're referring to the AI system or the model itself. And models can, interchangeably be referred to as AI models or machine learning models, or sometimes just models. So I noticed that there was a really big difference in the kinds of incidents we were seeing, depending on whether we look at the system as a whole. And the system can include, the model itself, of course, but also the data, any probably multiple models working on, in an ensemble style approach, things like APIs, any other kind of application or technology or data layer that's involved in the AI system. So if you think about a tool like ChatGPT, the underlying model is the GPT family of foundation models, whichever version you're using. And then the specific implementation is ChatGPT. That GPT model is adapted to be good at being a chatbot. But if you think about it at the system level, there's obviously a lot more going on than just a model receiving input prompts and then giving output responses. There's also a lot of input validation. There is the data that we as users are providing it, but also the databases that it has access to, either from the training perspective or, depending on whatever implementation you're using, an additional knowledge retrieval stage. There are things like feedback loops. If you're using ChatGPT through a different interface, there's API connection to be able to use that chatbot through someone else's app, and maybe there are bespoke elements added there. So if you think about the security of the system versus the security of the model, you end up with a really different conversation. And That makes a lot of sense because based on the kinds of conversations I'm having, usually people find it really hard to take AI security seriously because they say, oh, it's a subset of cybersecurity and all of our cybersecurity defenses cover, any potential AI security issues. And in many cases, that's a fair enough assessment, honestly. If you have really robust cybersecurity principles in place, that might be enough to secure the environment that your AI system is in, including all the data and potentially the model itself. What it doesn't cover is, anything that might be introduced that is new due to the model being in that environment, but also anything that's different in the way that you architect a system to be appropriate for a model versus a more deterministic software system that isn't that isn't an AI component. So specifically, the first thing that comes to mind for an AI system is that often a user is interacting with the AI in a way that they wouldn't really interact with a traditional software or computer system. We're all sort of imagining things like chatbots. So while there might be layers between the human and the model, things like input validation, even things like just formatting, it's still a slightly more direct way of accessing a computer system than we might have seen in the past. So I want to give you a few examples to put this system versus model perspective in context, because I think there are a few implications of this difference. And I think I'm interested to get everyone's thoughts on this specifically, because this isn't necessarily a conversation I've seen a whole lot in the space, or at least if it is, it's not really treated as though it's important, which is fair enough. This is just an observation I've seen, which has really flavoured the kinds of conversations and analysis that we're seeing. So I'm just referring to my notes here about a few incidents that we found as we were going through this analysis. So an example that I would consider a system level attack versus something on the model itself would be this Clearview AI misconfiguration. So you might remember is a strong word. You might have heard before of this incident where Clearview AI's source code repository, although it was password protected, was misconfigured. And so it allowed could allow an arbitrary user to access an account. And so this meant that a lot of the company's internal files, applications, and source code were at risk. So this external researcher gained access to the private code repository, and it contained things like production credentials, keys to cloud storage buckets with a lot of video samples, because Clearview AI trains facial recognition models, right? So there was obviously a lot of sensitive training data in there. And it also, they're also able to get access to copies of its applications and Slack tokens. So this was pretty significant, pretty severe. And the reason that we looked at this particular incident is because we would consider this more of a traditional cyber security incident. The means that the attacker or the researcher got in was because of these misconfigurations in their setup, which is more of a cyber issue than an AI issue, right? The reason we included it is because Clearview AI provides facial recognition models for a lot of security services. So we thought from an AI perspective, potentially they were targeted because of their AI, right? So it makes it sort of important to the space generally that we're looking at. So I would consider this example an example of an attack at the system level. The model itself wasn't necessarily attacked through an adversarial machine learning attack, but an attacker was able to get access to the training data that would have trained that model, information about the model itself, and then information about the way that the model would have been implemented through things like tokens. So for that reason, I think it's quite significant. But if we compare and contrast that to an attack which I would consider more of an ML security attack, in our analysis, a lot of these tended to be done by internal red teams, because if we're thinking about the layer of the model, this is harder for an external attacker to access. But it is possible, but there are naturally a lot of the resistance to ML systems being less likely to be targeted is just getting access to the model. So, it's fair enough a lot of the time. And so there are a couple of examples where, for example, Microsoft's red team. Microsoft has a very mature AI security practice. They have an AI red team that goes through and red teams and penetration tests all of their AI offerings. And so there was a Microsoft Edge AI evasion attack. It's a disrupt or deceive based attack, so you're able to get a classification or prediction model to not work as intended, or you're able to force it to classify or predict a certain thing. And the Azure Red Team performed this exercise on a new Microsoft product designed for running AI workloads at the edge. This exercise was meant to be to use an automated system to continuously manipulate a target image to cause the ML model to produce misclassifications. And they were able to force it to produce these misclassifications a lot of the time. And so this is an example where they're specifically targeting the model itself. They're not trying to get into the system where the model is. They're not necessarily trying to access or target or change any of the surrounding data, files, implementation, artifacts. It's about the model. So I think the reason this becomes interesting from an in the wild perspective, obviously there's a lot of research and academic work into ML specific attacks. And that's why it's often seen as quite an academic discipline that doesn't have a lot of real world relevance. So I think it's interesting to look at the sort of that bit in the middle where you're able to influence the model, but you're able to access the system. It's not just an internal red teaming exercise. And there are a few interesting examples of this, but I think this consideration of having to get it into the system and then having to affect the model really impacts the kinds of attacks that we do see in the wild. So there are at least 2 examples in our database of AI influencing malware detection models. So for example, there's one where researchers at Skylight were able to create a universal bypass string that evaded detection by Cylance's AI malware detector when appended to a malicious file. So they were basically able to insert an adversarial piece of data that when appended to a malicious file meant that that malicious file was never categorized as being malware. There was another example as well that I know mentioned in the last, or one of the last videos, where I think it was Kaspersky, their open source repository, they found lots of pieces of malware submitted so that it influenced the ratio of benign to not benign, i.e. malware samples, and meant that the model was less accurate. And so I think both of these are quite interesting because they're examples where you don't necessarily need to access the system to be able to access the model, but they can still be done in production environments. So for example, if you're adding into an open source data repository malicious samples, that's a means of accessing the system in a very legitimate way. Accessing the system doesn't necessarily mean you need to perform a cyber attack. In this sense, it is quite a legitimate way. It's very normal for open source community members to contribute their findings to then influence big, even proprietary models. Another example is this attack on machine translation services by Google Translate, Bing Translator, and Systran Translate. So researchers were able to replicate those machine translation services. They used the replicated model to successfully transfer adversarial examples to the real production services. So they use them as surrogate models. And the adversarial inputs to the real models successfully caused targeted word flips, vulgar outputs, and dropped sentences on Google Translate and the other translation websites. So this is an example where they were able to impact the system, and by that I mean the productionized language translation model, because they're able to create surrogate replicas just based on their own open source and academic research. So they didn't necessarily need to get access to the productionized system outside of just being able to launch those attacks against the models. But say if they had, if they were able to get copies of the actual models, that would have made it much easier, but they didn't need to. So this is another example where you can still implicate both the system and the model in very legitimate ways. Another one that's sort of related to, I guess, altering the malware classification models is, as an academic, and I don't know if there are other academics out here, I can kind of get around this one. Obviously would never do this in real life, but it's the manipulation of Scopus rankings by submitting intentional AI generated papers. So this blog was released by these researchers from the philosophy faculty at a university in Krakow, which found 3 journals published by a certain publishing company. We're now in the top 10 of the 2023 Site Score ranking for linguistic and philosophical investigations, because the journals were able to extensively cross-cite each other to get higher rankings. And that was because of the AI-generated papers that were created and submitted. So I guess you could almost consider this an example of algorithm hacking as well. But I think this is also quite interesting because this is a legitimate way of infiltrating the system and attacking the model. And so for all of those examples, it's in the open source project that I've mentioned a couple episodes ago, but I'm going to link those specific papers or examples down here in the description as well. So I think this introduces some really interesting questions about the difference between AI security and machine learning security. And for example, when I did my PhD, it was in adversarial machine learning. That was the name of the academic field, and it was very much focused on hacking, disrupting, deceiving, or disclosing information from machine learning models. And as a practitioner, you refer to it as a machine learning model, not an AI model. Especially, 5 to 10 years ago, right? AI was just the word that business people put on PowerPoint slides to advertise what you're doing, but you never really referred to it as AI. And the only reason that I've started referring to it as AI more recently is because the field has evolved, I guess, and a lot more people are now in the field of AI, and it has sort of evolved to be more acceptable among technical people to refer to it as AI. And that has muddied the waters a little bit in terms of definitions. For example, I always used to say, and back when I was teaching, I would say that AI refers to a goal, machine learning refers to a technology. And I still think that's true, but I've sort of just had to accept that most people are not data scientists, and for them, AI refers to the technical system. But I do think this leaves us with this interesting conundrum when it comes to referring to AI the technology versus AI the system. And so when I say AI security, to me that means the technical and governance practices that secure a system from external threat. But then if I were to, say, discuss machine learning security, that very much is focused on actually securing the machine learning model. It doesn't necessarily think about governance controls. It's much more focused on the defenses to adversarial machine learning tactics. And so I think this is an interesting open question for the field of AI security as a whole. What does that, what are the implications of that? Because maybe there aren't many, and it's just a transition that we're in the middle of, and we're going to see, resolved for better or for worse, for good or for bad, and maybe nothing will happen from it. But I think the way that I see it every day in my life, when I'm trying to tell people that they need to consider AI security. Not every organization needs to have an AI security team, but they need to have at least asked the question, are we secured? Are our AI systems secured? Are they safe? They need to be asking all of these questions. And so I'm just asking them to add, that AI security question to that list of questions. And most of the time, the kind of resistance I get is around them thinking of AI at the system level, and therefore not understanding that as a system, it might be a bit different to the security needs of other similar systems. So I don't know, I'm really keen to get your thoughts. The other thing that it makes me consider is the field of ML SecOps, which for some of you who may not have heard of ML SecOps before, back when I was working as a data scientist, I was the person who would create a model. I would spend 80% of my time doing data engineering work, and then I would pick a model architecture, I would train that model, I would test it, I would update it, but then to actually go to production, I would sort of hand that over to another team, and that would be the operations team, the ML ops team, and they would actually handle the implementation and the deployment, and it, they're considered quite separate disciplines. It's a little bit how in software you have people developing a software, especially as you become more niche, like application developers and engineers, and for any kind of software niche that you have. But then that gets handed over to the operations team, so the DevOps team, for example. And especially in cyber and computer security, as that maturation process of security from the start and embedding security practices into the actual process, so that at each step of the deployment you're thinking about how to do it securely rather than retrofitting it back on at the end. There has similarly been that sort of mindset shift within ML ops. And so we have this field called ML SecOps, which refers to all of the security processes you need to build into the machine learning deployment operations, sort of pipelines and things like that. And it's a somewhat separate discipline to that of a machine learning engineer versus a data scientist. But for me, it came up in this sort of question because the kinds of things that they deal with, I've just got my list here. So it's things like, you start with threat modeling, you have a risk assessment, you have to consider how to secure your data pipeline, model hardening, so this is where you might apply things like defenses to those kinds of adversarial attacks, and thinking about the robustness of your models, but in a sense this step is really done by the data scientist in actually building the model. At this step, an ML SecOps person wouldn't necessarily be updating the model itself, they'd be updating all of the things that go around that model. Thinking about secure deployment, so that's got a bit more of a cybersecurity flavour because you're thinking about access control, secure API endpoints, and then the monitoring and logging. And from an AI perspective, that means checking for things like model drift, checking for things like anomalies, suspicious activity, backdoors in data, all that kind of stuff. And so I think the relationship here between AI security versus ML security versus ML SecOps is another one where I don't think definitions matter as long as everyone is working towards the same goal and on all the problems that need to be solved. But the reason I do think definitions matter sometimes is when they help you understand better a problem that isn't currently being solved because you don't have the terminology to be able to speak to the people who need to be solving it. You wouldn't necessarily expect a data scientist, an ML engineer, an ML SecOps engineer to do all the same things. And so that's why it's important to consider. So I'm interested to hear from my audience. Do you know much about ML SecOps? Would you be interested in hearing more? I think there's a lot of parallels between everything else that I've already talked about and also in the more traditional computer and cybersecurity world. But I think the thing that I find with a lot of my listeners is that coming from a cybersecurity background, there are lots of ways that thinking about AI is, very similar and it's really easy to pick up. But then there's lots of things that are very specific to the world of data science and machine learning operations that it's important we don't take for granted. We want everyone to be able to start with the same perspective and the same knowledge. So let me know your thoughts about all of those questions. I think we're going through a really interesting transition when it comes to the maturing of AI security, ML security, and settling on the way that we discuss and therefore implement and give authority and ownership of different groups over all of those considerations is something that's really important now because we do have time to learn the lessons learned from cybersecurity and make sure that we're implementing them in AI. And these kinds of best practice roles and teams have become really, really important in cybersecurity. So that's it for me today. I'm sure I've bored you enough with discussions about ML SecOps, AI security and ML security. But please, if you haven't already, like this video, contribute to the conversation, subscribe to me on YouTube, find me on any other platform. I'm on LinkedIn at Harriet Farlow. I'm not very good at posting short form on Instagram and TikTok. I was trying, but it's just a lot of work. So that's it. I'll see you next time.